All right, great. So let's go back to our code. Go back real quick to make sure it didn't change. It didn't. That's good. All right. So a couple things you need to know syntactically about this. No code can exist between the catch blocks. So at the closing bracket of the catch and the starting of a new catch, there can be no code in between there. So you can't have any other operations going on. So it's strictly a catch block territory. You can't add anything else in there in that block. So and the order matters. So in this case, the most specific to the more generic in the way of catching errors. The really important thing to know is that when an error is thrown in the try block, it stops at that line. So if an error is thrown on line 17, the remaining lines will not be executed. So you need to make sure you keep that in mind when you are when you're working with try catch. Let's see. We're gonna a couple more things before we go through an error handling loop. What you could do is you can do something called multi-catch or multi-catch. So if you were to have, here it is. You have, for instance, in this case, I have two exception types. I have an input mismatch exception and an arithmetic exception. Two different types of errors, not in the same hierarchy, different hierarchies altogether. And what I want to do is I want to handle those two types of errors in the same way. If I handle the catch block code in the same way for both types of exception, I can combine them together by separating with a type character, which means that this catch block will handle either one or the other. There's some restrictions in this case. You cannot put an inheritance structure. So what you can let's start with. You can put as many of these as you want. You can have an unlimited amount of multi-catch in a single exception block, but they cannot be related. So I can't have an inheritance structure inside here. So what I mean by that is, let's say if I wanted to try to pipe in, for instance, exception at the end, that's a catch-all. It's not going to work. And why it's not going to work? Because the alternatives in the multi-catch statement cannot be related by subclassing. While all the previous input mismatch and arithmetic exception in this case are extensions of the exception, which means that there is an inheritance happening between those two and the exception, so therefore you can't have it in. So if you think about it, if you go back and look at this particular one, so there's two different trees. There's the exception, and there's a runtime exception, no such method exception, interrupted exception, and so on. If there's a subclass of any one of these, and I can pipe subclasses of all of these classes together, but I can't put string index out of bounds exception, index out of bounds exception, and runtime exception and exception in the same multi-catch, because they're all the same subclass. So they're related by being subclasses of the same superclass. But I could put a no such method exception and a runtime exception piped together and have the exact same handling happening for those two types in this case. So just going to go back and check this. Yeah, it changed. I knew it. Like that. So this is an example where you couldn't. You can do this, but you can't put the exception. So this is a way to handle multiple. Now, what you do in here again. So a couple things to keep in mind here. You can either print it. You want to be careful what you do. You don't want to necessarily push out an error that prints a stack trace to the screen for the user to say an error and blow all like you print up to the screen. Because it's not favorable. Nobody's going to appreciate that unless you're actually a programmer. So what you do is and this is what I said, like once you get into learning how to do I/O, in this catch block, that's where you capture the error into a file. You write it into a file, and then you have you have all the information in there. What you can do is you can put a kinder error message out there. So you can say something like, you can say something like system.out.println, and you can say please verify your input, or error, please verify your input. Again, now this is an input related error, which would be for input mismatch, but if you're handling an arithmetic exception in the same block, then you would definitely would have to have more generic error message. So what I'm going to do is I'm going to re-add this catch. And I'm going to do another one, system. Actually, we can copy that. An arithmetic error. And then the last one, you can simply go, an error occurred, and the program had to shut down, close. And in here, you can have a system.exit or something like that if you want to shut it down or whatever you want to do. A couple different ways you can do it. As another part of this structure, there's another block called the finally block. Now, you don't have to have a finally block. It's optional. Or you don't have, if you don't have a catch block, at least you have to have a finally block in there. But a finally block is it's a block that always executes, regardless. It always executes, which means that if there is an error in the try block, it'll activate, it'll throw an error, the error will be handled in the catch blocks, and then the finally block will run. If there's no error in the try block, it'll execute the entire try block, bypass the catch, and still run the final. As an example, we'll put some code in here to say this will always show up. Can you think of somewhere? What application can you think for a finally block? Why would you use a finally block?
At the end of when you put something, like let's say for a bank application, when you deposit money, you could say you have deposited this amount of money.
Well, okay, so you could, however, but what you should do is you should have the method in the bank, in the account class handle that, because that's a very specific operation. And if you put that in your finally block, think about this, what if you do more than one operation in a try block? All of a sudden you say you deposited, but what if it didn't deposit, and all of a sudden it shows up, right? So that, and what happened if it failed? If it didn't deposit, and it says on there, you deposited money, and all of a sudden you look at the statement. Yeah, so I'd say no to that one. But what else can you think of? Well, what can you use a finally block for?
When the customer logs out.
Logs out? Yeah, absolutely. But think about more in. So a finally block is attached to the end of a catch or a try. So think about in the scope of the try-catch finally environment. What could you use the finally block for? Think about the concept of it. Always execute, regardless if there's an error or not. You haven't done it yet, but databases. What do you have to do with a database? What do we do in database with PHP? We have to connect, and we have to disconnect. Finally, no matter what, if you have an error and it blows up, you want to disconnect. But if it's successful, you still want to disconnect. That's an example where you can use your disconnect. You can use your database disconnect. File streams, if you read or write I/O, input/output, you're going to have to open up the file buffer and you have to close it off. That's a perfect example where you do that. Anything you want to do that's going to happen regardless, if there's some operation you need to happen, whether it's fails or executes successfully, that's when you want to put it in. In this case, we're going to put it in there. This always shows up. this is when I demonstrate this and run it. If I put hello, it's going to blow up, but this always executes. This always shows up. If I do it successfully, 10 divided by 5 equals 2, this always shows up. So this finally block is a block of code that will always show up, always execute when you work with it. Now, if you think, okay, so let's look at this implementation right here where I'm reading a value. So I'm going to take this value right here. I'm going to take the read.nextInt, and what I'm going to do, I'm going to create. I'm going to take all these out because I don't need them. That's my main. So end of main. And I'm just going to do. I'll put this in here. Make it private. I don't have to do this. I'm just going to show you private static read number, read int. Private static int. Oh. I'm going to create a scanner. It's going to show you a way to work with this. So I'm creating a new scanner in here, and all I'm doing is read.nextInt and return that value. Now, so here's an example. So what we have is two keywords, throw and throws, that are key for, or that are important for error handling. What we use, we start with the throws. Anytime you define a method in Java that has the potential of throwing an error. Do we have a potential of throwing an error in this operation right here? What could happen?
Input type mismatch. So
input mismatch exception, absolutely. Because this method has potential of throwing an input mismatch exception, you have two choices. You can either create a try-catch block in here and wrap this code inside a try-catch. I don't recommend for that, and the reason why is because you want your error handling to happen where things are happening, which means that I want my error handling to happen wherever I am trying to work actively in my main. So down here, I have a method that's going to read an input, read a value for me, and it has the potential of throwing an error. But I don't want to put my try-catch in here. I don't want to have a whole bunch of extra code that's duplicated down in this end. I already have a try-catch block further up. I want to utilize that rather than recreating it. So what you can do is you can identify with a throws keyword. And you can tell what type of exception are being thrown in this method. You can say this method throws or has the potential of throwing an input mismatch exception. It could throw an input mismatch exception because there is an operation that could either read the wrong value. What happens in this case is if you want to use this method, if you want to use this method, you're going to have to wrap it inside a try-catch block where one of the catch blocks is either an exception or an input mismatch exception in the catch. If you don't, Java, the compiler will give you an error. Because what we're saying here, yes, we have a method. It has the potential of throwing an error. We're identifying at the top to say this could throw. This method will throw an exception called input mismatch if you have an error. So which means that if you're trying to implement this method, it is going to tell you, just like when, if I go up here and do nextInt, nextInt, notice that this documentation right here, if I go to the bottom, it says these are the errors that could be thrown for this particular method. It says throws. So these are identified. in the scanner class for this method, these are the methods these are the exception that could be thrown with this method. That's how we're doing it. We're doing the same thing now. We're saying, okay, if you're going to use the read it method, be prepared that one of the exceptions that can be thrown is an input mismatch exception. You can comma separate these exceptions. You can throw multiple different types. If your method is fairly large and has a lot of implementation, you can throw multiple different exceptions in there. So you simply would just put a comma. And you can keep going. You can add as many as you want. You can put, if it throws, or has potential of throwing, you identify them out there. What you're saying is you're telling the programmer who's going to be implementing this particular method that if you want to use this, you should be aware that you need to wrap this inside a try-catch block, and these are the type of errors that can be thrown with this particular method. In this case, we don't have an arithmetic exception, so I'm going to take that out. But we definitely do have the potential of throwing an input mismatch exception, and therefore, by putting this throws keyword in there, we're saying this method will throw it. This method throws the input mismatch exception if an error occurs. This is what it's going to throw. Now, notice that in the next thing, there was a couple of more. So you would just simply identify them in here by comma separated. We're going to worry about this input mismatch at this point. What I would do then is I would, instead of having x equals, I would just simply call read int like that. And then have this this input. So now, if I want to use this, if I want to use this, it has to have a catch block that handles the input mismatch exception that is being thrown. We're going to talk about throw in a little bit later, when we get to working with our. I think we can actually do that right now. Time-wise, it makes sense to do it. Let's start. Look, okay. So we're gonna. You can copy and paste this code if you want to keep it or comment it out. What I want to do is I want to, and some of you might have already done it, but in my main, I want to start writing a way to start interacting with the user. Because we have, well, at this point by midnight, we should have multiple different account classes. We should have multiple different customer classes. I think we said a customer, and business customer, student, and so on. We should have multiple different types of accounts, and if you haven't done customers, that's fine. You can do that for next week's lab. We should have multiple different types of two main headers. We should have accounts, dealing with accounts, and we should have dealing with customers. Those are the two entries we need to deal with. And then in here, we're going to make selections inside our loop or our menu to if we want to work with new customers and new accounts and so on, or existing. Existing will come with it later. But we want to start doing an interface, creating an interface that users can work with and see what's going on. And this is where we're going to start relying more on users and not so much on our own code. We know our own code should be good, but now we are actually going to rely on user input. And now it's our job to make sure we apply the defensive strategy in our code that they can't blow it up for us. So we're going to start with a very simple, yeah. Oh yeah, you don't have to do this. As I said, you don't have to. You can if you want, but this is this, and the reason why because it's a static method in main. We're not a big fan of. It is private, so it can't be implemented unless you're inside of this class. But still, don't want you getting into bad habits. I was just using it as a quick shortcut to show what was going on. All good? Okay. All right. So what I'm going to do is I'm going to take this whole try catch, but I'm going to take it out. You don't have to keep it either if you don't want to. I'm simply just going to take it out because we're not going to work with it. What I want to do is I want to create an environment where right now when we run this, it'll go through, it'll ask me for input, and when I'm done, it'll say build successful, and it's finished executing. I don't want to do that. I want to have an operational program that runs until the user decides to log out, or an error happens when I get it. But they're going to catch the errors. So what kind of loop structure? What kind of structure do I need to make that happen? A loop, yes. What kind of loop?
Do while?
Do while. Why do while?
Because it was in the lab.
This is in lab. Okay. So do while. Okay, that's what we're going to do. Now we're going to need some more code to supplement this, or to make sure this do while runs properly. And so I need some variables to make this working. I'm going to create a Boolean variable called keep going, and I'm going to set it to true. I also need a scanner called read equals new scanner. I'm going to create another scanner. Called account read. I'll tell you why in a sec. Put a quick comment at the top. So this is, I have a Boolean variable that I'm going to use, keep going equals true. And I'm going to use that down here as my variable sentinel, or my loop sentinel. So set it to true, so I'm going to keep going, and I'm initializing that to true because even though the loop runs at least once, if nothing changes, I want to have that loop keep going until the user actually hits a sentinel value, like an input from the setting, hit 0 to exit, or X or something like that. And then we can change keep going to false, so we exit out of the loop. But right now I want to set it to true, so I keep going by default until the user chooses differently. I also need to be able to store objects, and where am I going to store my objects in? Array list, absolutely. What kind of array list am I going to store it in? We'll start with accounts. Account, my account list. And this is going to change later into the part of your lab. And I'll give you the heads up on this. So right now I'm storing my accounts that we're creating here. We're creating an account. But where are we normally storing our accounts? Where is all our accounts to be stored? Where are they to be? Where do we store our accounts always? Well, yeah, the database preferably, but we don't know that yet. We're not at that stage. So where would I store in our code structure? Where do I store? Open up your classes and start poking around. Where do you see has a relationship to an array list in your class already? Maybe that means you go to the HR package maybe. Maybe look at customer. Is there one there? No, tell me. Do you see it? Okay. Is an account to be freestanding on its own?
No.
Where's the connection going to be? With the customer. So if the account belongs to the customer, does it make sense to have an array list inside a customer with accounts? Yes, it does. So we're creating an array list with customers right now, just temporarily. You're going to change this later, and it's going to become something different, which is part of your lab. And you're going to start something different in there. Why? Because we're already dealing with accounts. Make sense? So we're going to do something. We're going to do accounts now as a demo, and then when I give you the lab, you're going to modify it to something else, which is likely going to be Right now, we're going to deal with accounts because that's the easiest way to deal with it. I don't want to do the lab for you. That's why. Anything else? We'll create an account variable in case we need it. My account. We're just not going to initialize it at this point. Simply just going to work with it. So I created a, so we'll put here list to store accounts, which will later change. And this here is account reference variable in case we need it later on. Here I'm going to put a system.out.println line. And I'm simply going to be courteous and say, welcome, actually the capitals, welcome to Java Bank. Why am I putting that outside the loop? Well, because we don't want that to be inside the loop every time we go up to the beginning. Welcome. Well, you already said welcome. And then, again, welcome. So we put it outside the loop once, so when they actually log in and start using it, pops up, good to go, and then we can start working with our loop. So we'll give a quick comment. Now, so in this loop structure, we're going to have a bunch of messages. So the first one we'll do system.out.println because we want to tell the user what to do, right? Or give them some options. So the first one's going to be, please select one of the following. Next one's going to be system.out.println. Then we're going to give them some options. So one, employee management, customer management. Customer management. We'll do account. We'll change it later. Account management. And then I'm going to create I'm going to do a /n for a new line. And two, customer management. We'll do 3 for exit. The /n just simply means a new line. I'm creating one system.out.println, and the /n is just saying create a new string that is on a new line for all of these. So what's our next step? Now, what are we going to do next? Read the user's choice. And how do I do that? I have an input variable integer right here. Input equals read.nextInt. Now I have the user's input. What do I do next? Yeah,
You start doing
If statement, absolutely. So what should I do? If input equals 1, else if input equals 2, else if input equals 3. And I'm going to add an else in here as well. Why do I use my else block for in this case?
in case they don't select anything else.
Yeah, if they give me 4. Yeah, if they give me 4 or 5, which is not on the list, we're just going to deny them. I'm going to go system dot out dot print line.
Please don't use it.
Yeah. Please. Actually, at that point, I'm not going to be kind anymore. I'm going to say provide invalid input. And I'm actually going to point this out because I've seen a lot. I've seen a lot of assignments. I marked a lot of assignments through my years as a teacher, and I've seen sometimes people students putting in, and it turns me up, and it's quite an icebreaker when they do. But sometimes they'll put in like, "Can you not read, dummy?" or something like that. And as much as it's just me reading, it's sort of funny. I talk about it. When you go apply for a job, there's nothing more valuable than bringing portfolio work. And at this point, how much portfolio work do you have? Not a whole lot. You have it with your class, right? So that's what you can bring with you to show. And there's nothing out there that's going to crash your interview faster than having a profanity show up on the screen when you're trying to run your software. And there's like an HR director who's trying to poke around all of a sudden, "Hey, can you not read, dummy?" You're sort of at the bottom of the list when it comes to being selected, if you had it all being considered. So as much as it's funny, and you know what, I sent quite some funny messages. I don't personally care. It gives me a good laugh, but be really, really careful. You don't bring that to an interview and actually just have that happen, because I've seen it, and it's not fun. Yeah.
In the other class for Java, one of the students wrote bitch face as one of the names for a teacher object. Just not trying to attack the teacher, but teacher saw and wrote an email saying, why would you do that? What did I do? Blah, 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 blah. You're going to be in big trouble.
See, that's exactly because if you, give both ways, I think if you as a student or as a teacher, you leave stuff in the class, suspended from the class, if the teacher feels threatened, right? You're not going to threaten me with that. I'm okay. So that's not what I'm saying. What I mean is, you don't know when that's going to come up and bite you. So try to be cautious. Invalid input. Yeah, it's like, hey, invalid input. I'm going to put a please in there. Please try again. Just be courteous because, as I say, you never know when it's going to hit you, right? And sometimes output messages are really important. How many people ran Windows 98? How many people use Windows 98? Okay, so your system that's performed an illegal operation and will shut down. How many people run with that message? Right? No, there was a little error message that showed up. An illegal operation has been performed, and it's going to shut down. Well, if my mom was reading that, I'm always 80 years old, she's going to read that. My God, something illegal. I didn't
Going to jail.
She's the most honest person. She finds $1 million in the bag, like completely untraceable. We didn't know it in there. Nobody can trace it, spend it. She will bring it back. And so for her to do something illegal on the computer, that would be the last year to do. So sometimes output actually doesn't matter, right? Like it's important to do something more. Yeah, and that's please try again. And we can also do a smiley just to make sure that we're showing that we're at no, we can't because do that either. Sad face, capital C, sad face. How's that? That doesn't interfere with our parentheses. Never mind. Take it out. All right, please try again. All right, so now we have. What was that? Yeah, I know, but sometimes it could have unexpected outcomes. So okay. So first of all, let's pick up the easy one first. What am I going to do if input is 3? Let's exit. What am I going to do? We exit the loop, right? How do I do that?
Change the keep going false.
Yes. It's now when I hit 3, it's going to get to this point right here, set it to false, while keep going. And so you may not, if you're not familiar with what I'm doing here, by leaving this in, like this without any comparison, it's going to assume it to be true. Which means that you're comparing this to be true. This is exactly the same thing as if I were to put, same thing. So by taking that out, it's assuming that it's comparing it to be true. Now, if you want it to be false, and you put an exclamation mark in front of keep going, then it's going to negate that to be not true, which means false. Make sense? All right. Yeah.
So, define keep going equals true at the beginning.
Yeah.
Boolean keep going equals true.
Yeah.
Consider that you already know that it's a Boolean to give true or false. What happens in declaring the Boolean? Just like Boolean keep going. That's it.
It's assumed to be true. There's a default value for every primitive data type in Java, and it's assumed to be true. It can't be maybe. Yeah, it can't be maybe, perhaps. It has to be true or false, but it'll assume one value. It's always a good idea to initialize where you want it to be. In this case, I want it to be true because I want this loop to run for all, as long as the user doesn't put 3, it's going to keep running. So by setting it to true, you're priming that value, that data value, to have a value in it already. All right, so let's look at the next one. So this one here is going to be customer management. We're going to leave that to later, and this here is going to be account management. All right, so in here, now we're going to work primarily with the account management portion, because I'm going to get this loop portion ready, and then you're going to write the rest with error handling for your loop for next week. So, so now I have, now what I need to do is I need to create another integer called int emp input. And why am I creating another emp input? To handle input for the employee. Because I don't want to have I don't want to cross-contaminate my inputs. So if I have an outer loop that has input 1, I don't want to have any more value. I want to have that value residual in my internal loop. So I'm creating an inner loop here that's going to work with just employees. I'm going to go through that loop until they decide to exit back to the main menu. And because the input loop is already used, you can reset them and reuse the same variable. I find it's pretty cheap to have a separate variable for the internal loop for the employees. That way you're separating the two, not getting confused. Because if you use the same variable and you're using values back and forth, it's very easy to get lost and have an error occur. So in this case, I created an input variable for my outer loop structure, which is just going through the outer loop. Once I go into one of the blocks, one of the menu items, which is not input, but account management at this point, I'm going to create a new variable, not emp, sorry, account input. Account input. Now I'm going in to deal with accounts. Well, I'm going to create a separate single int variable to deal with that internal loop. That way I'm not cross-contaminating data values back and forth. Make sense? All right. So and this is going to be used for my inner loop that I'm working with. I'm also going to create a Boolean called keep going, account keep going. Now there's a little bit of overhead in these to do this. If you're comfortable working with the single outer variables and not creating internal ones, that's fine. I'm doing this primarily to show students who are new to this that this is an easier way to work with. If you feel that this is overhead that you don't need, you can definitely work with the outer single variables if you want. I find this is an easy way to learn it because you don't have to worry about keeping variables separate. So now at this point, I'm going to create an internal loop. So now I need an inner or nested loop for account management. Again, it's going to be a do while. And I'm going to use that until keep going, as long as keep going is true. Of course, I have to set value to be true up here. Back. So my account keep going variable, Boolean variable, is going to be set to true, and I'm going to run it as long as I have that value to be true. All right, so now we're going to do some output here. We're going to do a system.out.println, and I'm going to type some values about, please select one of the following. Create new account. I'm going to concatenate in another one. Look up existing account. Or we're going to have one more that says return to the main menu. Notice how we have a lot of these messages coming out. Now, not a problem to keep them in the code, but I find personally that they clutter up the code and add a lot of values that are lines of code that I don't need to manage at this point. Can you think of a place where we would better have these messages? Can you think of a way to place this somewhere else?
Maybe a method.
A method, absolutely. What's can you elaborate on that?
Like a method would say like main menu, you type it out and then you type this out.
You're 93% correct.
93.
Yeah, almost there. Think about it from there. What do you think, Gabriel?
How about making a brand new class that will be connected to the main?
I'm going to challenge you to say, do we already have a class we can use?
Switch grid?
Oh, no, I don't like switches. I mean, we'll talk about that another day, but I don't like break statements, so I use to. But what could we use? Take a look at your application started so far. So any class in here we can use that can store an output like this. Take a look, scroll through. Is there another class that services us in some way?
Service class.
Service class. Somebody coughed it out. Yes, service class. Exactly. Let's take so with you being 93% correct, but adding that method into the service class makes you 100% correct. Does that make sense? Yeah. Okay. So what we're going to do is we're going to create. We're going to open up our service class, and in here I'm going to create we're going to just put a quick header in. Menu methods, just to give us a little bit of some formatting. So I'm going to go public, static, void, and I'm going to start making these messages. So the first one is going to be main message. And inside the main message, I'm going to go up and take the one we first did, the very first one. Put it right in here. Another one called account message. And I'm going to take the next message I created right here. What's the benefit of doing this?
The same reason why we
Yes, it's modularizing. We're putting it into separate classes. If we need to change that message, rather than having that message over and over and over again to multiple different main menu, I change it in one spot.
also the main message is pretty much.
Yeah, you want main leads, so I'm putting it in a separate class, but I'm making them static. Why am I making them static?
So you don't have to create an object.
I don't have to create an object, and does it matter if these are static? There are no implementation, there's no data value, there's nothing but a string in the system, a print line that will always run. You can't break this no matter how you try. If there's no object creation, there's no object creation in this environment. It's not relying on another object from main or something like that in another class. It's simply just relying on system classes, which is printing it to the screen and putting output out. That's all it's doing. So if I make that public static, and somebody wants to hack and implement this and show my messages, go ahead. I'm not going to lose any sleep on that. So it's not a big deal. But if I have a static method inside my main that is public, that is relying on objects being created in main, now you have a huge problem because if I can go to that method directly, start trying to manipulate those objects that have not yet been created, now you have a big problem. This is not an issue. This is perfectly fine. To call it,
Excuse me.
Yeah.
After M3X, there is input equals read.msn.
Pardon?
Is supposed to be the main message.
which one?
From the main.
Yeah.
Before I was having a notice that was input equals read.msn.
Yes, no, that was just a demonstration for main, so don't worry about that. Leave that in for now. We can take it out after. So the first one right in here, this is what I'm going to call. Now to call it, I need to go service class dot main message. And in my second do while loop, I'm going to go service class dot account message, because I'm now in my account portion of creating it. And you guessed it right. Let me just verify that this hasn't changed. It hasn't. That's good. What other class in here? You're likely going to have a public static void customer message. And I'm not going to put anything in there because that'll be part of your lab. So Gabrielle, this part right here, this method.
Up top.
Yeah, we're calling this method from up here. Where you, what line?
Just a little.
Oh, in here you mean?
Yeah, that one.
Okay, you can, if you want to, you can, it gets a little bit more complex at this point, but you can also put this in a static method for sure. However, if you're trying to call that static method without having the input variable, you can cost yourself some grief, right? So I would be careful about doing that at this point. The last method here, you can take this out. We won't need it. Static method at the bottom. Now, so at this point, we have selected one to get into account management. I'm in here right now. I have a bunch of variables. I put out my next message, which is create a new account, look up existing account, return to the main menu. Okay. So what I'm going to do is I'm going to get an input. So how do I get the input? Yeah, I'm going to use account input. Account input equals, and this is what I'm going to use. I'll use my account read at this point. Now, what we can do, actually, we can take this account read, because that account read will only function, it should only function inside of, in here. So you can paste it inside your if block. So it's only used if account is chosen. Again, now I have a choice between one, what did we say? 1, 2, and 3. So again, I need to have an if statement. So if account input, account input, not account read, equals 1, I'm going to do something. Else if it equals 2, I'm going to do something different. Else if it equals 3, I'm going to do something altogether. Else it's an invalid input. So same thing. Now again, I can also take this invalid input message and put that in our service class, because we might be calling that a couple of times. So let's just simply put it in here. Then system.out.println. Now, I'll leave that up there. So creating a static void method. Now the value with this is if I want to change the output message, if somebody does an invalid input, I change it in one spot. Call the same method over and over again, but it's done in one spot. So back in main, where am I doing that? Well, I'm doing it right here. Service class dot invalid input. And I'm going to do the same thing on the outer part right here. Actually, to stay consistent, make this message invalid input message. That way you're staying consistent.
You said there was a second one there.
Yeah, at the bottom, the other 3 input, sorry, add or else at the bottom. Just before the outer loop. Get it? Yeah? Okay.
Thank you.
No worries. We're going to focus on reading information from the user input right now about the account. So I'm going to open up my account class. Now, keep in mind that my account class is abstract, so can I create one of these? Right, so I didn't make my account, I haven't done mine yet, so account, so checking account, that's all I have. So I'm going to copy this. The constructor for the checking account at this point. And I'm going to put that in comments in here, just so I know what I need to do. However, account input 1 should be creating a new account, correct? So at this point, I can only create checking accounts, so that's not a big deal. But if you need to create many if you have the opportunity to create multiple different types of account, you need to have another selection in there, which means another nested loop, do while, right? So you can see that these get quite complex. You can get quite granular with these. But at this point, we only have a checking account, so I'm just going to ask for one because I want to get to the objective of today, what I want you to do. So I'm going to go system.out.println. I'm going to say, please enter, and what's the first thing I need? Balance. Account balance. Now, I have nowhere to store all this data, so what I need to do is I need to create variables for this. I need to create a double balance, and I also need an overdraft limit, and an interest rate. Let's initialize those because IDE will complain if we don't. What else do I need? I need an int for year, month. Okay, so please enter account balance. And here's my account read. I'm going to use this again. So account read, so balance equals account read dot, but in this case, I'm going to read a double. So I'm going to use the next double method. Next value I need is the year. I will do overdraft limit first. Please enter the overdraft limit. Yeah.
All these values calculated are simply zero because they're just being created.
I'll tell you why in a bit, because what happens is Java will complain if you don't have them initialized, because later on what we're going to do, and you'll know in a bit why. Okay, so just take it for value at this point, and I'll explain in a bit why. Because later on we're going to put everything. Each one of these are going to be put into a little separate do while to read, so we can loop around. If they don't get the right value, we're going to loop around until they do enter the value.
So you still need a starting value.
Yes.
And by default, you start from zero.
0.0 for double and 0
Yeah,
for
of course.
yeah.
I mean, you will start from zero as a default.
Yeah.
Starting point.
Yeah. So again, we're going to read a double up here. Yeah, we're reading the interest rate. Fixed double. I'm gonna copy these. This is just for time savings purposes. Now we're going to change this to month, and this to day. So year equals and we're reading an int. We're doing the same thing for month. And the same thing for day. I can take that out because I don't need it anymore. So I'm reading all these values into variables. These are the variables I defined up here. I define them in here because they have the scope of this if block, and I won't need them after this if block is executed. So I don't need to put them at the top for use later on. When I have all these values, I'm going to go. Well, what do I have here? I have an account list, and I created an account. So my account, I'm going to create an object in my account, and I'm going to store it in my account list. So how do I do that? Well, I'm going to go my account equals new checking account, and this is how we can use our inheritance is a relationship because I can store it in an account. And I'm going to provide values. These are the values it's going to need. It's going to need a balance. Going to need, let me go back and get this again. It deleted it. Balance, and then year, month, day, overdraft limit, interest rate.
Should be account my account.
Yeah, no, because we already created it. If you look up here, we already put that in here. Okay, and notice up here I created an array list that can store accounts. So what I'm going to do now, I'm going to use that array list variable, and that has been created. And I'm going to add my account. Make sense? Once you get the hang of writing these loops, it takes you about two to 3 minutes to do. Just getting through the structure and knowing, putting everything in logical sequences and like separating and modularizing it. Once you have it down, it's pretty straightforward to do. I do recommend when you do the lab, start fresh to get a little more exposure. Use this as a reference to get it started. However, that's not we didn't really want to talk about loops today. We talked about that a couple weeks ago. But what is a major concern with this loop right now?
Wrong input.
Pardon?
Wrong input.
Wrong input. Yes, it's going to happen. We give this to users, I guarantee you it will happen. So what are some potential issues that can happen?
Putting in words, and things numbers.
Exactly. We can get hello into the year, or we can get false into the balance. You can get anything because users they don't have the understanding that we do of the system, right? So how do we fix it? Try catch, our best friend. Yes, we're going to do a try catch that's going to catch all the errors that are going on. Now, what I tend to do in here, I tend to create a Boolean that's called account flag. I'll tell you why in a bit, and I'll set it to true. What I'm going to do is I'm going to, for each one of these, I'm going to create a try catch. Now, what I want to do is I want to have a loop that's going to have them go back over and over again if there is a potential glitch. So what I'm going to do is I'm going to do a do while for each one of these inputs. I'm going to go and I'm going to do while. And what am I going to use? Well, I'm going to use an account flag. While the account flag is true, keep running it. And what am I going to do? I'm going to use exactly what at this point I'm just going to put exception. We can modify this later. I'm going to put a try catch around this. What it is, I added the account flag and I created a do while loop. And I'm doing that only around the first system out and balance, the first input. Okay, so what do I do now? I'm reading the input. I have the value. What happens if I succeed? What should I do? Go to the next one, right? How do I get to the next one? It's a do while loop that runs as long as the account flag is true. How do I get out of that loop? What do I have to do with the account flag? Yes. Why do I, so as a last line in my try block, I'm going to change that to false. Why can I do that? Well, because, what?
Oh, I was gonna say, because if those other two lines are fine, then we'll automatically do that one.
Exactly. If this is successful, it's pretty hard to break system that has the print line. So if this is successful, balanced, I get read the account balance from the user. If they do that right, then I've done everything I need to do for the balance. I don't have to do anything else. I've stored a value. Next thing I can do is change the account flag to be false. Then I exit, I bypass the catch. While this is true, well, I set it to false, so that's not going to be true. Therefore, it's going to exit the loop and keep going. But if for any reason it blows up right here, and this line is going to jump out, not change it to false, it's going to jump out into the catch, and it's going to handle the error. What we're going to do at that point?
You just do the print stack trace.
No, never. You know, we can do that at during development. You can do that absolutely, but if it's a user, what do you want to do?
Just query for another, or say that you entered the wrong input, try again.
Do we have that? Yes, we do. Service pass dot invalid input message. How many times we're going to use that? Probably for every one of these, it's going to be an invalid input message, right? So we're going to push that out to the user. So having that in a separate class makes a lot of sense, particularly if you want to change it. Because if we decided that all of a sudden not to be kind anymore and take please out, you have to go through the entire loop of the main and figure out exactly where it was. Now we have it in one spot, a lot easier to manage. Make sense? All right. So what you can do, and this is sort of obsolete, but what you can do, you can go account flag equals true if you're nervous. It's not required, but it's just another safety net to guarantee that if for some reason this has been changed to false before, we set it to true in your catch block where the error happened, because then you're guaranteed that it's going to run again. What's going to happen is this is true. It's going to go back up to the do while and run it again. Try it again. And it's going to keep reading that input for balance until you get the right value. Now, and I'll show you this as well before we have to go. If we, for any reason, want to make sure that we don't allow zero balance. If they're trying to put zero as an entry, we're not going to allow that. We don't want people to, or staff to be able to say, enter a new account with a zero balance, because the core requirement for our bank is that to deposit $1 million and you sign up for an account. That's like the minimum, like $100, let's say. So we want to say what's going to be our minimum deposit for a checking account? Throw a number out.
100.
100?
100.
100. Okay. So if what we're going to do is we're going to create an if statement to check that. If balance is less than 100, what we can do is we can throw a new exception. Throw a new exception. This is slightly different from the throws keyword. Remember, the throws keyword is associated with a method that has the potential of throwing an error. So the programmer that's using that method knows to encapsulate it inside a try-catch block and handle the appropriate error. This here, throw, deducting the S, no S, means that a new error is being thrown. So we're saying, okay, throw a new, if the balance is less than 100, throw an error. Because we don't want them to, like 0.0 is a valid input for a double. But we don't want that. If that value is less than 100, if they're not putting in, actually it should be 100.0. My bad. Or if, let's say, you're reading customer information and somebody enters an empty input, they just had a space bar, or they do something that they shouldn't do, like some other value. You can have a bunch of restrictions you're going to check. But this is what we're doing, is saying, if balance is less than 100, throw a new error, generate an error, because we don't want that to happen. So rather than having another if statement and the do while in there, oh, you enter 0, go back up. Nope, just we have the potential of throwing our own errors. We can throw an error in Java to say, using the throw keyword, throw new. You know, new is what? Calling the constructor for what? The exception. So throw a new. Really, this is create a new exception and throw it. So throw a new error called exception. What's going to happen? At this point, it's going to stop execution because there's a new error created. Java knows that this is an error created. Jump out what you're doing. Go find a catch block that can handle the type of exception we created. And then it'll go down and run again. So even if they enter 0.0, they can't get away from us. We're going to throw an error, we're going to throw it back into the loop, we're going to react at the top again, please enter it.
So I understand kind of like the implementation of it, but wouldn't we want to say a specific error message for this kind of thing?
Yes, that's an exception. So this, we don't do it as in course, but you would write your own exception.
Okay.
And you would say like Steve's exception, or make it out, or even better, invalid account balance inputs. And then you would throw a new one of those and you would handle that as well.
So is that better in Java to just make your own exceptions, or is it easier to just have an if statement and then print that, or it's Java, print line?
Yeah.
You inputted less than 100 when blah, 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 blah. Like, is that better to throw an exception or to just print the message and try?
You can throw any exception you want. You can throw any exception. You can throw a new index out of bounds exception because you control it, right? It just would be weird if you did because it doesn't have anything to do with index out of bounds. So in this case, we're doing exception because it's generic. But yes, you can write your own. If you have a need for a specific exception on your own, you can't find one in the API that can handle it, you can do that exception on your own. You can also create methods inside exceptions to implement if you want to do certain things, right? So, but that's a little bit more advanced than we're going to do at this level. But you can do anything you want with those exceptions. When the exception happen, because remember, it's generating an object that's stored in the error. So this becomes, if you have an exception and it's stored in here, you have a method, you can implement that method. You can print to a log file, and that's typically what you do. You create a log file, in a high up level of the exception structure. You create log file method that is then inherited by all the sub exception, subclass exception. You can implement that to write the log file, because it's all done behind the scenes. No one sees what happens. Make sense? But in this case, you just and I'm not saying. We should do this all, but we'll do it just for arithmetic. Now, this is going to be caught by the exception, but we can do this because we don't have our own exceptions at this point. And then this is what we can do is system.out.println. Please enter a value greater than 199 dollars according to our logic. But if you do this, we don't have our own exception at this point, so we're throwing in an arithmetic exception. There really isn't an arithmetic exception.
So I could throw a array out of bounds exception and
And handle it. Yeah. But you don't want to do that because it makes sense to you because you had nothing else at hand. But if another programmer comes in and said, "Why are you throwing out? There's no array here," they get confused. And a programmer that's brilliant enough is going to look at that and say, "Yeah, there's nothing else available." That's why you throw an exception, right? A generic exception. Whereas this here probably shouldn't be an exception. This should probably be an input mismatch exception because that's the most likely to be thrown in the previous error. Make sense?
Yes.
Okay. Yeah.
In Java, it's still allowing the key value. So for example, if you have a menu with 3 options, it only is with 1, 2, and 3. Nothing else is allowed. So you would need to throw it out as someone said hello instead.
That's part of the defense. I could probably teach you an entire year worth, 2 courses worth of defensive programming strategies and that's something that's going to come with time. Right now, it doesn't make sense, or you might look for certain solutions, but as you go along and you start looking at your code, what I always recommend is when you're done this term and you take this and you put this code and you move in and never look at it again, don't do that. Put it in on a shelf somewhere and come back in a year or 2 years and look at that code and see, how can I refine this? Because that's how you're going to get better, right? Because when you take in the next course and you've done all the advanced Java and all that, look at how can I improve my previous code? Because you have a lot of code that you can work with at that point, and it's a good exercise to look at that, how to make it better. It's a really good exercise. I do it all the time. And at some point, I've gone from having 8,000-9,000 lines of code in a piece of software down to 300-400 because you can really consolidate. I'll give you an example. So at this point, it's almost time to go, but bear with me. At this point right here, this is another, and I do this on purpose to show you, but I have a variable in here called my account, which is an account variable, and I create a new checking account that is assigned, and then I'm assigning that right here. Can I streamline that? Can I make it more smooth? How?
You can directly assign my account to my countries.
Yes, but you can omit it. You can go like this. You can take this whole thing, put it in here, take out my account right here, but then you can also save yourself the creation in memory of a variable up here called my account because we don't need it. Right? Done. Now you saved a couple lines of code, and what I'm doing is I'm creating the object directly inside here and assigning it to the list. Done. So as you can see, this here has, if I were to label error handling, it's not only try-catch. It's try-catch, which is one thing. That's one part of handling, so your application doesn't blow up. That's your structure. But this is the finesse. This is the interior decoration right here. Doing stuff like this. Making sure you have 2 while loops for every input. Making sure you defensively narrow it down that even if they try to put something in and they don't get it right, too bad. You're going to do it anyways. You're going to force you to do it exactly what you want. But forcing people and eliminating possibility, take options away from the users and give them the options you want to give them, because then you're guaranteed to get what you want. You're frowning when I say that, but do you agree or disagree?
Yeah.
Do you agree? Do you not disagree?
No.
Neither? No, but like the more options you give users, the more variables you have, not variables in terms of variable data, but like variable outcomes you have, they're going to mess it up, guaranteed. So if you have a path and you say do this, this, or this, and they try something else, no, go back and do this. It's like training a kid or a puppy. You got to train your users on how to do it. But defensive programming strategies is really important. If you stray away from that and you need users' options, it's not to say that you should say your software should have 3 items and that's it. No, give them options, but make sure you control their options. Because by controlling their options or their input and what you want them to do, you're going to have your software not go up. Because guess what? If your software blows up, who are they gonna call? And who is going to have to set up the fee in the morning, figure out a patch? Not me, right? And the more times you do that, the more you get into that. You know what? I'm going to censor that. I'm going to say, don't give them options because they're going to screw it up. They are. It's a fact of life. It's going to happen. They don't think that we're a very unique set of people because we're here to learn to write software and code to make our computers work. They're a very small percentage of it. Look at this. Hands up if you enjoy this. Be honest. You will. How many people in society do you think enjoy this? No one. When we look at this makes sense to us. We wrote, we created this, we did this. But other people look at this and go, nah, I'm just gonna hit something. Because they don't care. No, it's true, but it happens all the time. Trust me, I work with so many users. And it's gonna blow up. And they go, doesn't work, never works. And it can blow up once a year, and it never works when you call it, never. And then all of a sudden you go, oh my God, what happened? And that's why you need to have a log file, because if you don't, they're gonna make up stories. Oh yeah, I tried it 6 times today, and it blew up 50 times yesterday. When you look at the log file, it blew up twice in 2 years. But that's because they don't want it. People don't like change. Right? Trust me. So what's your lab? This is going to be fun. Your lab, you're going to finish this entire loop structure, which means that you're going to read account, and you're going to read, you're going to read use the customer input. I'm going to write this up and post it, but I'm going to give you a heads up. You're going to get the customer input, and inside the customer input, you're going to incorporate this account thing you just did. Because when you create a customer, you also have to create an account. So you take all the customer data, and you say, when you're done, you're going to ask them, what type of account would you like? And you're going to loop through until they pick the account that's functional. And then you're going to get all the account data entered, and then you're going to create the customer with all the account data to it. Make sense? And every single input line that could potentially go wrong is going to be covered by 2 things: try-catch and defensive programming strategies. So when I run that, and this is when I run it and I get a single error, you get a 0 on the left. So
You look excited about that.
I'm pumped. I'm not going to sleep tonight. I can't tell you that. No, I'm doing this because I want you to go through this with a fine-tooth comb. It's not due next week, but the week after. I'm giving you 2 weeks for this lab, which means that it's going to be a bigger lab. It's going to be a lot more marks. It's going to be double marks.
But 1 error gets you 0.
You're trying to break
Would it be more advisable to show
So
that
find
before
it. So
submitting?
find a user that can break it for you. Go find someone who's nursing for that. Not okay. No. I mean, no, it's recording. Okay. Not nurses are brilliant people. I'm not saying that. What I'm saying, find someone who doesn't do computer programming, that doesn't think like you do. That's what you need. That came out too long. I recant that statement. Find someone not in your program. You can try to break it. Hey, can you give them a coffee? Here, here's a coffee. We're trying to program. Trying to break it. Seriously, that's it. And when you find out how many people can do that for you, get a Brad. You need a Brad. I have a Brad. We have me all the time. Are you Brad? Get a different Brad. Yes.
For defensive programming, it would be like, says, please enter the day, and then in brackets put like.
You could, yeah. Oh, that's brilliant. Yeah, use samples. EG, yeah, or your IU. Yeah, example, yeah.
Okay, I have a habit of using switch statements. Do you never want to see a switch statement?
No, I say to new programmers, don't use switches for 2 reasons. I don't want you to be in the habit of using breaks outside of switch statements. I don't ever want to see a continuous statement in any of your loops. Those are 2 really, that's go-to programming, and I cringe when I see it. So what you do is, if you want to use a switch, you can, but there's a break in there. And this is what I've seen before. Students go in and they start using switches and they see the break, because they have to use it. They don't know what it means, but it's in there. Oh, what's this? And they go look it up and they say, you can break out of any code by using break. Then they use that in like a for loop or something like that, and then they get lots of mark reduction because they use it. That's why I don't tend to use switches until you know what you're doing. In advance, you use switches because you understand how to break out of a loop without using break, or how to run it using booleans and if statements to continue it and so on. That's when I'm okay with using it. But if you know you had 2 years,
Yeah.
Not with Java, but using Switch statements.
So I'm okay with that. Anybody can use it, but I'm saying for your own, don't get used to using breaks outside of that, because that's the only time I'll accept. They got penalties.
Okay.
Make sense?
Got it.
Any questions? Does this make sense? Can you see the value behind
What's-
exception handling?
What's the assignment?
Assignment is going to be building, that's what I'm saying, this is the part, you're doing part of the assignment right
Is
now.
this like we're getting pretty close to the whole assignment, right? So
Mhm.
apart from adding customers and accounts for each customer,
Oh, this could be.
is there
awesome.
more?
Oh, yeah.
Oh, lovely.
There's more coming.
Okay.
Because what the assignment will be method implementation inside of classes. So we're building the framework right now, but when you actually deposit, withdraw, create a customer, call a customer's name, all those things, the meat and the methods are going to be the assignment. So I'm giving you the framework, and then I say, this is what I want this whole thing to do. Because that way, because you have no idea how many versions of the do while loop I've seen throughout my years, so what is it, give you that as a here's a tool. Now make this happen, and then you very specific criteria what an account should do, what a customer should be able to do, what the service class should be able to do, and you have to build that inside the thing. But by giving you it open-ended, it's going to be a complete nightmare, Mark, because I get so many different versions of what an any given group should look like. Right? So that's why I give you this first. And then you can just do that.
Sure.
Sense? Yep. See the value behind exception handling? Right? Right? Tired? Been a long weekend? The couch all weekend? You know, it's time to get back to work. See you next week. Yes, I will, but I'm gonna
What's that?
want you to do it yourself.
Okay.
Try first,
Well,
and use this
I
last.
won't say yes just yet. What's the favorite?
I
Okay.